Hello and welcome to NARC Live on Wednesday the 26th of January 2022. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7URP. You're good to see you. On tonight's show, learn more about Ferrites and Balluns with Kevan N4XL. Messaging by text or Morse. Which is fastest? And we find out what on earth this is. Now, I don't wish to give too much away. This has foxed more of you than many weeks as I can remember, well before Christmas. So if you have an idea what this is, have a good look now. It's not too late to let us know, either on Facebook or BATC, and we'll read your entry and we'll put your entry in when we read out in about 5-10 minutes time. What on earth is that? But we start, I'm afraid, with some very sad news. And I'm sorry for any shock or distress that this will cause. Because I'm sorry to bring you the news that Ian Coleman, G4GBT, has passed away. To many of you, he'll be best known as the chairman of Great Yarmouth Amateur Radio Club. Personally, I last saw him at our Barford social meet in July last year. Our sympathies and thoughts, of course, with his family, friends, and the Great Yarmouth Amateur Radio Club. Ian Coleman, G4GBT, silent key. Now some news from our president, Malcolm G3PDH, and he says herewith the affiliated contest results for NARC. In the RSGB AFS contests run during January, NARC have so far achieved the following positions. NARC entered the local club section and teams comprise groups of 4 based on individual scores, Team A being the highest 4, then B the next 4 scores, and so on. In the CW contest on the 8th of January, Team A was 6th place and B and C were 13th and 24th place respectively out of 57 club entries. NARC made a very strong entry in the data contest on the 16th of January with a repeat win of last year, with Team A in 1st place, Team B and C in 13th and 24th place. Sorry, I've read that wrong. And B team in 4th and C team 11th, then D team 34th out of 42 entries. Although we're still awaiting the results for the SSB contest that took place on the 22nd of January, we're hopeful of a top 3 placing. So another great result for NARC, and congratulations and thanks to all of you who took part. The next RSGB Club contest is the start of the 2022 Club Championship Series with SSB on the 7th of February. Other club members wishing to participate are very welcome and should make contact with the committee or directly with Malcolm or with Roger G3LEI for more information on how to get started. The club also holds a contest net every Friday night at 2100 hours on 145250 MHz FM to assist and advise newcomers to contesting activity. Now, the other thing I'd just like to add as a rider to that, which came in from our membership secretary and treasurer, Mark G0LGJ, during the week, is a reminder that if you do enter any of these club championship contests, you do have to be a member of NARC. So it's a timely reminder that if you haven't already joined, we're just about to leave January, which is normally kind of the time when we ask people to rejoin if you want to rejoin without sort of leaving the club and then having to rejoin. You need to join now. The membership, whilst we meet online like this, is just £5 a year, regardless of age or anything. It's considerably less than it was, and that just helps the club cover its basic fixed costs like insurance and affiliation to the RSGB and things like that. But you do need to be a member of the club if you are entering for club records. Let's not lose any points if you're not. So it's a reminder really, if you want details of how to join Norfolk Amateur Radio Club, look, the best place is to go onto our website. You'll see there's a story there on page 1 or 2 on the front of the website. and it will give you a link of how to join. If you're already a member and it hasn't quite lapsed yet, although it's about to, at the end of the month, then you can just simply pay the money and let Mark know with an email saying that you've paid. But all the details of how to pay, ideally by bank transfer, but there are other methods like a cheque or PayPal if you wish, although there's a small fee associated with PayPal which we have to pay. But anyway, all of the details are on there. There's the website address there, norfolkamateurradio.org. Now, Ken M0KJW sent us this. How about this for a QRZ card that he found on Facebook? All I can say is wow. Now, I'll give you a little bit of time to have a look at that. I don't know if you can see all the details, depending on what device I guess you're watching this on and what sort of internet you've got. It says it's DL2ART, and it says the life of a German ham radio operator, but it's done in kind of Monopoly way, and they've got DL2ART. Well, I'll hand over to our pronunciation expert, Tammy M0TC, for giving us the pronunciation. What does that say, Tammy? You normally get this first go.
What? Which one?
In the middle, it's DL2. Come on, it's easy, isn't
DL2ARTopoly.
Yeah. Wouldn't it be DL2Artonopoly or something?
No, because that's his call sign, DL2ART,
okay.
Anopoly.
Oh, all right. I thought you might come up with something a bit more. Anyway. All right, so look at that. He's got his years there from 1979 elementary school, then 1983 high school, etc. He's got free ride from mum's car. I love that one at the bottom, in the middle there. In the bottom left, which is normally in jail, I think it is in the army and just visiting. So he's done it exactly like a Monopoly board.
The one on the side, it says UHF tank, pay 1.6 million euros.
Yeah, on the left. It is good. Have a good look at that. I won't leave it up for too much longer, but it is really good. And if you want to have a look at it yourself, I dare say if you search for social media. Look at the top one as well. Sports car pays $50,000. Or euros. Sorry, euros. Yeah, it's upside down. Yeah. Anyway, it's great. It's the story of his life, really, all around the board. I thought it was lovely and very novel. Be very happy to get a QSL card like that, wouldn't you? Thank you, Ken, for sharing that with us. Now, at the beginning of the menu, as we call it, I asked you, what do you think is faster, text or Morse? Now, I guess some of that is going to be generational, how old you are and how much you ever get into texting or not. Maybe that's a bit easier now with smartphones.
How quick you can move your thumbs as
exactly,
well.
Those first phones, you know, those Nokias and things like that, when we originally texted. I know some younger people could text a lot quicker than me, for sure. But what do you think is faster? If you're good at texting, is it text or CW? Well, I'm pleased to say that Gordon G0HQJ found this on the internet, on YouTube, and he thought we'd like to share it with you. You may have already seen it, but if you haven't, have a look at this. This was on the Jay Leno show, one of the big famous chat shows in America. Let's have a look at this.
When I say ready, set, go, when I say go, flip over your card and send the message to your partner at the other desk, okay? Ready, set, go! Yell out as soon as you have the message and then read me the message. You can hear the Morse code? Can you hear it going on?
Yes, I can.
Okay. Very exciting. Let's see who is faster.
Oh my goodness. Morse code. I bet you can see that coming a mile off. Do they have to wear that visor thing? I don't know what that was about. Is that the early telegraph people, I think? I don't know. We'll have to ask Roger or Malcolm or one of the other aficionados of Morse. Anyway, bit of entertainment. Thank you very much for sharing that with us, Gordon. And finally, some bits and pieces, really. Last week we carried out a story from Tom about a transmitter that you could make using just two 555 timers. Now, 555s were a classic little 8-pin integrated circuit, probably around the 70s, I think. I started using one of those as a kid, and they were a classic, not maybe so easy to find now. Now, if you're interested in making that, the article that Tom referred to last week, Dave G0ALJ let us know on the Monday Night Net that he's got quite a few of them and he probably never needs to use them all. So if you're interested in making something like that and you need some 555 timers, contact Dave either via QRZ or you can contact him via us. I'm sure you'll find his email address out there, and I think he's going to give them to you. Probably he just wants a good home and find for some of them. and maybe making one of those transmitters. So thanks for that. Now the other thing is, just before Christmas, you'll remember, I'm sure, the filter kit, the mains filter that GM3SEK Ian came and told us all about in the club, and 42 of you ordered kits or bits to make those. Well, one of our members, David G3MPN, has actually got a kit that he doesn't need anymore. It's a complete kit as bought from us just before Christmas. He's willing to sell it at cost, so if it's a standard kit, it'll be £51, and that's for everything. So if you missed out the first time around, and I know a few of you did, then if you contact Dave, G3MPN, if you have his details, you might hear him on the radio, or if not, if you just send me an email to radio@dcpmicro.com, there we are at the bottom of your screen now, I'll forward the message to him and you can arrange to buy it. He lives in Wyndham and he said it's just going to sell it at cost price to you. So if you're interested in a filter kit, this might be your last chance to get one at something like that sort of price anyway. Now, little people, that's me done with. Tammy, your little people.
Here's the little people for this week. It's called astronomy. No, I couldn't say that. Astronomy.
Astronomy, maybe? Okay, oh, and they're made out of all drinking straws.
Yeah, it's cool, isn't it?
Oh, yeah, the little bendy ones.
Yeah.
Before they all went to paper, most of them now.
Yeah.
That's good, isn't it?
It looks pretty cool, doesn't it? It looks pretty convincing.
And I like the tripod made of them as well.
Yeah.
Very good.
Cool.
Miniature-calendar.com. New picture every day. You've even got the stars in the background. Yep.
It's all good.
Brilliant. Very topical as well. You were out there the other night.
I was,
Do you want to tell people briefly about that? We didn't plan to talk about this, but you were doing with the Unistellar. What were you doing?
We did an asteroid occultation.
Mm-hmm. And that was, and you sent the data though of that, the pictures to SETI, wasn't it? You said that.
Yeah, so it's a scientific research program where they have they use people's scopes, and if you're in like a band, like a viewing window, you can use your scope to video basically. They give you the coordinates, they tell you how long, the exposure and everything that you need to set it to, and from the raw data that the camera records, they can basically see that this asteroid that you're pointing to goes across a star or some bright object, and from that they know exactly your GPS coordinates and they know where you're looking, and they can determine things about the asteroid and learn more about it.
And they're building up a picture because lots of other people join in as well and do this.
Yeah, possibly. Or you may well be the only person that's doing it at that time because you might be the only person in that viewing window.
Right.
So we've done 2 now, haven't we, in the last week?
Good cold, but a brilliantly clear sky.
Yeah.
An occultation.
Yeah.
So anyway, what have you been doing? Some of you have written to us this week, but we'd love to always hear from you, your news, your pictures, the things you find on social media like tonight. Always find us, we'll always have a good home here. Send them to this address, radio@dcpmicro.com. If you send them to us by 3 o'clock on a Wednesday or earlier if you can, then we'll usually make that programme or shortly afterwards.
We've got just a couple of comments on the Morse thing. Chris Danby says it's chip K7JA at the key.
Oh, he knows him personally?
Yeah. Well, he knows of him, I guess. And then Malcolm, G3PDH, says, not sure about the visor other than in a sunny, bright room. They had cuff covers to stop their shirt cuffs getting in the way of the key.
Oh, I didn't notice the cuff covers. Okay, but the visors, they often go with the telegraph operators. If you're of a certain age, you might remember a program called Casey Jones way back. When I was a boy, that was one of my favourite things because it was a train. Yeah. Anyway, they had telegraph operators then, and they always wore the sort of visors and things like that. I'm just going to mention also one of the other things that comes up. Someone's actually just replied to it. So something changed with Facebook. It's not us. We haven't done anything, and there often are subtitles that come up at the bottom, which of course is ideal, especially if you're hard of hearing or maybe you've got to watch it in silence or something like that. That's nothing to do with us. We're not putting those subtitles out. But you'll probably find it's a setting that you can do, and in fact
we've just done it, haven't we?
Steve G3AVA asked, is there a way you can switch them off? And Mike Mobbs has come back and said click on the CC box at the bottom and then click captions off. So there we are. If you're seeing those and you don't want those captions, you'll find it's a setting on your Facebook. It's nothing that we're sending, it's automatically generated.
It's not us.
Clever stuff though.
It is clever stuff, yeah.
Anyway, let's go back to what on earth object. Have we got any entries for that? We haven't.
I haven't seen any, no.
Because I think at this point, when we show you this, is anyway, let's have a look at it. What on earth is this? That was last week's object. Now, for the last few weeks, many weeks, well before Christmas, we've been deluged, really. In fact, we have a sort of, I think we could loosely call a script here, 4 pages normally. And I have to reduce the font size to be able to fit everything in our sort of format that we've got. But this week, we have just 1 entry, which is extraordinary compared to all the previous weeks, even the ones that I thought, like the Venetian blind cutter last week and everything. So, not many of you. If you've got a guess, you need to put it on very, very quickly. If you do know what it is, I'm just looking. There are none, are there, Tammy? No guesses. So no. We just had 1, and this was from James M0JGX, and he says, I've got no clue for this week's, but I'm going to say it's some sort of HF vertical for Tammy's little people. Because it is it's a sort of telescopic thing, isn't it? It's a real gadget. It does look weird, doesn't it? But yeah. I'm amazed that nobody's guessed it. Not that I knew, I have to admit. No. Not at all. So I think we now kind of have to reveal what this is with nobody entering. We do. Well, we might have a little lag, so we can always read one out in the next sort of 30 seconds. Yeah, we will give you half a point if you get through after we've read it. But anyway, this is what it is. Now, it was submitted to us by John, G0MXN. Sorry to hear you've not been very well lately, John, but anyway, I hope you're feeling better today. And this is what it was. It's a butane gas match for outdoor use. This is the packet that it comes in, a perma match. He actually mentioned to me on a subsequent message that his wife, sadly no longer with us, but Shirley loved gadgets and things. And this is a gadget that was never actually used. But anyway, you fill the yellow container with gas, remove the wand and strike on the strip at the end of the container. There's a wick through the wand which lights when the tube is pulled out, and the wick end, which has been soaking up gas, is struck on the strip on the bottom of the container. Like many must-have gadgets, it's never been used, he says. Wand is telescopic, so you're well away from whatever you're trying to light, especially barbecues. I think that's a brilliant gadget. Sounds like a good idea, doesn't it? But it is one of those things, it's probably one of those things, dare I say, I might even buy. I think that's really good. I didn't actually use. So. Yeah. Anyway. We have those ones now, don't you, that create the spark. Yeah, that's true. We've got one of those, haven't we? Sort of the coil we bought thing. A Christmas so ago. Anyway, I think that's absolutely brilliant because for the first time in absolutely ages, John, you have, John has floored everybody because we didn't get anybody answer what that was. So well done to John in this case. That's a perma match. There we go. So we're ready to see this week's object. Have a good look at this. What on earth is this? Now, a few clues have a good look. There are quite a few clues, but you've got to work out what on earth is this, or what on earth is this used for. Have a close look. We will, as always, be putting this on our website and on Facebook and on our newsletter this weekend. Have a good look at that, though. As Tammy said, there are some good clues there, but you've got to work out what that is, not just describe it. It's one I know, actually. Does it? It is, yeah. I almost didn't use it because to me, it's one of those things, I think, not giving you any clues except if you know what it is, you'll know. But for everybody else, you've got to reason it. Well, sometimes you can reason it out. I think for everybody else, you can reason it. Not always. I mean, that this week's one from John, that was very difficult to work out from what you saw, what it did. But that one, I reckon you might be able to reason out. So have a good look at it when you get it on the newsletter, on the website, on Facebook, and let us know by 3 o'clock next Wednesday what it is. So before we get to tonight's main event and our guest, let's just tell you what's happening at the club this week. On Sunday at 7 o'clock on the GB2RS News on GB3NB repeater at 7 o'clock. On Monday, we've got the Monday Night Net at 7:30 with host Ken M0KJW. That's also on MB repeater. And at 8:30, the 80-metre CW net on 3.543 megahertz. And next Wednesday, here on NARC Live, the 2nd of February, we're going to do more on the GM3 SEK filter. Now, this was the box, if you remember. And as I said earlier, 42 of you ordered either the filter or bits and pieces for it, but a lot of you ordered the complete kit. I think something like 35 complete kits. So if you are one of those, can you give us some feedback? There's a couple of things we want. So next week's all about that. It's an informal. It's going to be by Zoom. And if you bought any of these bits and pieces, you know, I've got some of the main parts from here. There's the mains filter itself, one of the filters. There's some of the input of ferrite. And of course, they came in a box. Now, lots of you, I'm sure, I'm betting, you haven't actually got around to making it yet, but I'm sure a lot of others you have. And for those who have, we would love your feedback. In fact, what Ian asked, now I should also share with you, by the way, that I told Ian what we were doing. He was very pleased that so many people have made it, and he has offered to come on next week. So he'll be amongst you on Zoom. So if you can join us by Zoom, that would be great, because you'll be able to ask Ian questions yourself. Maybe you've found it effective, maybe you haven't found it made any difference at all, or it's, you know, done half a job. Ian actually suggested that we did some kind of straw poll and found out how effective it's been for you. So you can watch us on BATC and Facebook as you normally do, but ideally if you can join us by Zoom, especially if you've made one and you've got results from it. If you haven't, try and get it done by next week, because this is all about sharing that information. We've never had a kit that's been so popular, I think, apart from maybe the NFED half wave a few years ago that we did, especially when it's just a filter. I was particularly blown away by how many people want to make it. So let's have a discussion about it now you've had a chance to make it, and let us know how it is. And that will be on next week's NARC Live, 7:30 here. And finally, of course, just let us have your details of all of your news and everything by here, and your answers to the mystery object. And of course, just to let you know as well, that we have this card which we're happy to send to anybody. It's the Norfolk Amateur Radio Club card. We'll send this to anybody who wants to be, you think should be cheered up, not feeling too good at the moment, has a birthday or an anniversary or something to celebrate. We're always happy to send that. Again, just radio@dcpmicro.com. Send us an email and we'll be very happy to send this card to them. Now, on to our main event. Now, Kevan N4XL is no stranger to here. He's come and given us talks many times before. He's from Greenwood in South Carolina. And well, the weather was not too good to him last week, but without me explaining any more, before we talk about it, maybe let's go to Kevan now. Good to see you, Kevan. Thank you for joining us tonight.
Well, thank you for inviting me again.
So the weather wasn't great, and I think when we corresponded early last week, you hadn't got any power at that point, and it was possibly going to be several days before you got any.
It was an ice storm came through, and fortunately, the weather mostly went north, and we ended up being on the fringes of it. But we were out of power for about 30 hours, and I wasn't sure I'd be able to do the presentation or not. As I'd mentioned a little bit earlier, there was a time a few years back when a similar storm came through, and we were without power for a week and had to go to a hotel. So we were sweating this one a little bit, even though it was so cold out.
I bet it was really cold. In fact, I know it's quite a distance from you, but John G0MXN has a friend, Don, in the States, who often actually comes on to here. And he just sent this a few hours ago. He's heard from Don today. He lives near Indianapolis Airport. And I quickly had a look at the map. And that's about 600 miles, I think, Indianapolis from you, isn't it, in South Carolina? But to give us Brits here an idea, we think it's cold and raw at the moment. In Indianapolis at the moment, today, it is minus 11 degrees Fahrenheit, the wind chill, which is minus 24 degrees Celsius. And the dew point is minus 21 degrees Celsius. So that is darn cold. So maybe we should, as John says, we shouldn't complain too much. But thank you very much for coming on tonight, Kevan. We're going to learn, I think, more from you about ferrites and balluns. So over to you. And as always, for you at home, if you've got questions or comments to ask Kevan at any point, just put them onto YouTube, onto BATC or on Facebook, and we'll read them to Kevan straight at the end. But back to you, Kevan. Thanks for joining us.
All righty. Thank you very much. This presentation came about from when I was building my contest station. I didn't have an Elmer who taught me a lot about things, but these are some of the comments that people had talked to me about balluns. They said they don't work. Problems got worse after I added one. Just put a few turns of coax in a coil, diameter bleach bottle, you'll be fine. Should have one with your Yagi, otherwise it'll mess up your directional pattern. Somebody else told me he's convinced they even worked, but since they're only $35, about 25 pounds, just put one in there anyway. Not out much by putting one in. Another guy said I burned one up. So I started thinking about it. I said, do I really need one of these things or not? And this is an outtake of that quest to find out what they are and how in the heck do they work. I do not claim to be an expert at this, but it did answer a lot of questions, this search. And I renamed it Ferrite and Common Mode Chokes because that's predominantly what I'm looking at rather than the transformation principles of Balluns. But we'll talk about some of the principles of Balluns as well. A man named Roy Llewellyn, W7EL, wrote this. He says, I've always been a bit bothered by Balluns since I was never sure what they are supposed to do, let alone how they might go about doing it. And some of you who are familiar with him may recognize that name and call. He's actually a guru of these, and he actually coined the terms current and voltage Ballun and did a tremendous amount of research on them. And I always got a kick out of his quote. I was following in some big footsteps when I started on this quest. My goal is mostly to present an overview of why ferrite and common mode chokes should be used in your shacks. It's not a how to build thing, although we're going to give a couple references about how you can build them and what the different advantages of some of the construction techniques are. I'm going to start out fairly basic. Most of us have seen the inside of coax before, a center conductor, some dielectric, and then there's this braid. And a lot of people don't necessarily think of the braid all that much. They think of it as just a regular old conductor. Let me get a laser pointer here. But there's actually an inside and an outside to that braid because of skin effect of RF. And most of our wanted energy flows on the inside of that braid as close to the center conductor as we get. But common mode, sometimes stuff will come out, and even though currents go in one direction on the inside, it can actually be flown back down in the other direction on the outside of the braid. And that's basically what common mode current is. And an example of that, in a pictorial form, you've got a center conductor, and this red represents the braid. From your transmitter, you get some energy going up on the inside of the braid, and it goes out into the antenna. But at that junction point, there can be a little bit of an imbalance, and some of the current flows back and starts interrupting with things in your radio shack. And that's basically what common mode current is. And we're going to talk about how we eliminate that. How do you get these imbalance points from different things? We throw an antenna up, and the dipole is a balanced antenna, looks the same on each side. But if you notice in the field of that antenna, we've got all these feeders, the wires, all the metal that may be inside of your home that's not present on the other side. And that's one way you can generate imbalance. So the same thing can happen with trees if you don't have any metal around anywhere. It just naturally happens. And of course, your antenna construction, maybe this droops a little bit more down on one side than the other, or whatever the case may be. There's always some type of imbalance, even though they call them balanced antennas. One of the questions at the beginning dealt with the distortion of the directional pattern of a Yagi. I found this online. A guy had done an easy neck examination, and the black shows the regular pattern that you would expect to get out of this Yagi that he was modeling. But with common mode current, you can see not much of a loss of forward gain, although a couple dBs, but pretty well destroys the front to back ratio of it. So if you're looking for an antenna system you really want the front to back ratio, Ballun is a good thing to have for that part of it. I have a link put out by IZ2UUF, and let me bring this over here and blow this up a minute. And it's just about 3 minutes long, and it's a very good explanation of how you can get common mode current problems inside of your shack. This man is very intelligent.
Often, ham radio operators debate whether a one-to-one Ballun is needed on resonant dipoles or not. To test the effect of a Ballun on a resonant dipole, I built a dipole for the 40 meters band with a switch that can bypass the Ballun. The first test is the measurement of the VSWR. As we can see, the curves with balun or without balun are almost identical. There is no way to see the balun effect with a VSWR meter. Now we shall perform a radiation test. A transmitter will be keyed, while the balun will be alternatively inserted or bypassed. An RF emitter will monitor the amount of power radiated by the coaxial cable. Another RF emitter will monitor the power radiated by the power cord. We can now key up our transmitter. When the balun is disabled, a significant amount of power is radiated by the feed line. Without balun, even the power cord radiates. The paddle cord also radiates. Electric shocks can be perceived when touching the base. In this test, we shall use a signal generator to simulate a source of noise nearby the coaxial cable. Such sources of noise, like switching power supplies and others, can be met by the coaxial cable along its path within the house. So, let's turn on our signal generator. The injected note is very evident when the balun is disabled. The lack of a balun has no significant effect on VSWR. However, it causes significant radiation from the feed line and other wires. It might cause higher noise due to feed line pickup. Thank you for watching.
So that kind of convinced me a little bit there. Let me pause this and make sure he doesn't keep talking. That kind of convinced me right there that
I'm Dave Kessler.
That a balun was probably a good thing to have inside of the shack. And, now a couple other questions came into play. If it does so much that, as he said, how do you go about using them? Why would they burn up, or some of the other things that these people were talking about? One thing that other people have told me before we get into that is if you use shielded cable, you probably can cut down on a lot of that noise. But as the common mode current illustration pointed out, it flows on the outside of this braid, so it's not necessarily going to cut down on common mode noise at all by using properly shielded cable. What it can do is keep you from radiating the signal from the inside out, and for that part of it, it's a good thing to have. And the different types of cables that you have out there, RG58, 8X, and 213, only have about minus 55 dB isolation. And it goes up with the different designs you have. And the LMR 400 has about minus dB isolation. So even if you don't buy coax to eliminate your common mode current, it can prevent the noise from being radiated from the coax. And in fact, energy that comes off this coax can be induced in the braid on other parallel runs and other wires. So it can help a little bit from that aspect, but not as much as people might think. Jim Brown, K9YC, he's another person I consider a guru, wrote this. He says, shielded cable rarely solves RFI problems, partly because to do anything useful, cable shielding must be continuous with the equipment shielding, and lots of equipment to which you'd like to connect it is unshielded. And we're going to talk about that in just a minute here. He discovered something, and at least he's the first one I ever heard that talked about it, called the pin 1 problem. And this is one reason, a major reason, why a lot of our equipment is susceptible to radio frequency interference, or RFI. We've got a great radio here, Elecraft K2. And the problem is these little connectors that are on the front. They design these cases to unscrew all those screws on the top and then take the case off so that you don't have to do anything to disconnect those connectors. But they're not grounded to the radio case itself. And if you open it up, you're going to see that those connectors are still there. And they are grounded to the chassis on the inside, so you think that that's good enough for grounding, at least I did for a long time. But that sets up the very condition which can cause common mode current to get inside of our equipment and cause problems. And he has this little picture on his website showing how we just saw, rather than being connected to the case of the cable, it goes inside to the circuit boards on the inside, when really what we ought to have is it connected to the casing on itself. So problems does this set up? Well, common mode current is coming along in on this coax cable braid, and it's going to come in here into this system trying to get to point 2. And to do that, it has to go through these different components. And it might just be a regular old piece of copper, and you're thinking there aren't any of those components in there. It goes right straight to ground inside. But the very existence of the copper traces on the inside on the circuit boards causes a resistance and an inductance, and in some cases capacitance, which at RF generates an impedance, and on an impedance you get a voltage drop. And that voltage drop can actually cause some of this common mode current, RFI, to go right up inside of your signal circuitry, and that's why you end up getting a lot of the noise. And you might think, well, I don't have that problem on my particular issue, but you probably do. We're going to see that in a second. The key to a bail-in, or the key to reducing this, is to put a very high impedance out here and get most of the voltage energy developed outside of your signal circuitry and prevent RFI from being a problem. And that's what we're going to figure out, is how we can use a bail-in to do that. Here we have an antenna. We'll put a bail-in out there with a high impedance, and hopefully all that energy will be developed across the bail-in rather than go inside of the signal circuitry. Common mode choke. Pin 1 problems are not limited to coax. He was actually a design and an audio engineer at a concert when he started looking as to why he was getting RFI picked up in his audio cables. Ferrite can help reduce these on control lines, power cables, mic cords, etc. This is a Carver stereo system, very high quality piece of equipment, popular back when I still had hair, back in the 70s and 80s. And you can see on these audio cables that they've got these little rubber rings right around them. So these aren't connected to the chassis either. And although we used to, audiophiles like to use shielded cable, that didn't necessarily help us all that much. Here's a laptop, and that strip for the sound card in and out, mic in and out of a laptop, that's not grounded to the case of your laptop either. And here's an Astron power supply, an RS-35M that Jim, K9YC, had looked at. And I used to think everything was perfectly fine. I'll just connect up to that little stud on the back of my equipment and everything will be grounded. Well, he opened his up and took a look, and Astron had painted the section where this little lug connected on there. So if the screw happened to contact the metal, you had kind of a poor connection. But that ground lug might not necessarily help you out at all. I checked mine, and in fact, mine was that way, and a few other people, as I've given this over the years, this presentation, have said that they've discovered the same thing. And I'm sure other pieces of equipment also had painted chassis on the inside as well. So your ground chassis connection is not necessarily a ground. We've got another presentation here to show. And this is what Ferrite actually does. This is a little bit longer one. But it was pretty interesting too. Let's go ahead and get this started.
This video is going to talk about ferrite beads and kind of some of the filter applications for ferrite beads. There's lots of other applications for inductors and RF toroids and transformers and such, but we're just going to talk mainly about the filter applications for ferrite beads. And a lot of different forms. A lot of times you'll see these large kind of split core beads that you can put on wires to reduce interference and provide some filtering. In fact, if you look at a lot of the computer cables that you have hooking into your computer, like the USB cables, like this one for my mouse, that's basically a ferrite bead sitting under there. And we're going to talk about what job it does there. You'll also see sometimes just simple little cores like these guys here. maybe you want to hold holes in them to make a transformer or a winding like this one here, making like a little bit of an inductor, or just a simple bead on a wire. Okay, and how do these work? The ferrite material is a high permeability material, so it makes it easy to get larger value inductors when you make a winding out of them. But also at higher frequencies they introduce loss, and what that means is that at high frequencies they essentially start to look like resistors. Okay, so they're not really ideal inductors anymore, they really just look more and more resistive. Okay, and so in other words, they basically add loss at higher frequencies, and sounds like a nice thing when it comes to doing filtering. And just to kind of show you the effect of that, I've got a simple little setup here. My signal generator is set up to do a sweep, let's see, from 10 kilohertz to 40 megahertz. Okay, and I've got this going into this little block down here that has, you know, basically the signal coming in, going through this wire, coming back out again, and then up into the scope. And I've got the scope set to look at that, you know, that's the whole sweep. So essentially the signal that's here, okay, is running at 10 kilohertz, and then it's sweeping all the way up to 40 megahertz at the other end. Okay, so if we put some frequency dependent device in series, you know, right here, we're going to see that effect on the scope. So in fact, what I can do is if I reach over here and grab one of these ferrites, I'm just going to grab one that's easy for me to deal with in my hand. So it's got 2 holes in it, but I'm only going to use one. Okay, and if I kind of pull this wire off of here, slip this ferrite on there, okay, and let's see if I can get this thing to kind of jam its way back in there and stay in place. Okay, so now that that ferrite is just on the wire, I didn't do anything else other than put the ferrite on the wire. Let's look at the scope. We can actually see that the response now, you know, 10 kilohertz is really not affected, but I get out to about 20 megahertz here, and I've lost some amplitude. I go out, you know, and you can see it's kind of flattening out. But with doing nothing more than slipping this ferrite on the wire, I've introduced some loss, and that's mainly because that's essentially a series resistor at those frequencies. In fact, if you add more cores, it just gets better. So if I take and open this guy up, throw another core on here, okay, and see if I can make that guy stick. And now I look at the scope. Now I can see by the time I get to the middle of the screen, which is about 20 megahertz, I'm down about, you know, half the signal amplitude, or in this case that would be you know, 1/4, you know, less than half the power, you know, 6 dB down, right? So just by slipping some ferrite cores on there. Now if you take and put some windings through a core like this one here, you know, that makes it a lot more effective. Okay, in fact, if we take and bridge this guy across here, look at how effective that thing is. So at low frequencies it's passing just fine, but as soon as we get up to a few megahertz or so, I can see that it's really introduced a lot of loss. So that's a pretty effective filter for high frequencies. Okay, so another way to think about that is, you know, it's really kind of restricting, you know, the high frequency content. And so that's one common use area is for like EMI suppression. And that's one of the reasons why you'd find them like on computer cables. You got some high-speed signals going through some of these computer cables. And if you've watched my video where I talked about the frequency content of square waves, you will know that the faster the rising and falling edges, the higher the frequency content you have. So let's look at that same effect and how the ferrites will you know, affect the high frequency edges or the high speed edges of signals. So I'll switch my signal generator over here to a square wave that's continuous. Okay, let me connect up my wire here again. And if we go to the scope and kind of speed this up here, I can see, let's turn the brightness down in the scope here. Okay. So I can see some really pretty fast edges on this square wave here. In fact, so fast I can't really see them. Okay. In fact, it's got about 2 nanosecond edges if I kind of speed the scope way up. You know, there's 5 nanoseconds of division. You can see it's less than a division, so it's a really fast edge. Okay. And if I take, let's take just as an example that multi-turn, you know, ferrite here, and if I connect that up here, look at the resulting square wave. You can see that it's really just taken all the edges right out of it and taken and filtered them away, kind of making it almost look closer to sinusoidal. So what it's really done is remove that high frequency energy from that particular signal. So you can actually see that it would help to maybe reduce the radiation of that high frequency coming off the wire and interfering with radios and other things like that. So that's a very common use case, is for EMI suppression. Also, another good use case would be for like improved power supply decoupling. Here's just a little schematic example. Maybe I've got an IC here, I've got some local decoupling here. Sticking a ferrite bead in series with the power supply coming in, what that will do is two things. One is, if there's any high frequency energy being generated in this chip and it wants to come leak out the power supply, the decoupling cap can short it to ground. But if this ferrite bead wasn't there, it might also propagate out onto the power supply plane. Okay, so what this does is ensures that this capacitor looks like a lower impedance than the rest of the power supply plane, and it makes it more efficient. Also, similarly, beads can also block higher frequency energy from coming in through the supply, okay, as well. So typically used for some power supply decoupling. It may also be used for controlling parasitic oscillation. Okay, those of you that may remember a video that I did about a year ago, where we talked about this circuit here. Let me kind of move over it. And the concept in the video was talking about analog oscilloscope bandwidth considerations, meaning how much bandwidth do you need in your scope to measure whether you're working on audio signals or whatever. And I had built this little circuit here, which is a simple audio oscillator. This oscillates at about 2.5 kilohertz or so, but it also had a parasitic oscillation in it. And so if we kind of switch the scope over to look at that, I've got the circuit built up right here. And if I switch my scope over to look at this, okay, let's kind of get this kind of going here. All right. So you may remember some of these waveforms if you looked at that video. I'll put a link to it in the notes there below the video. And what we're looking at is the base and collector voltages of this circuit down here. So I'm looking at the base right here and the collector voltage here. So the collector, we're just seeing that oscillation, or the regular sinusoidal oscillation as intended. On the base, we're seeing this thing burst into a high frequency oscillation, here and here. And the point of the previous video, to talk about bandwidth, was that if the bandwidth of the scope was less, like 20 megahertz, I wouldn't see that oscillation where it really is there if I go to full bandwidth. So I talked about a way to kind of get rid of that oscillation. And when you're dealing with bipolar transistors, it's often necessary to have some lossy impedance in at least 2 of the 3 nodes. And in this case, I really only have it in 1. And what I did in that previous video is I added a little bit of resistance in series with the base, an actual physical resistor. But the same thing can be accomplished with the ferrite bead. Okay, so very easy to see the oscillations here. If I come down and look at the circuit, okay, there's the circuit built up on the board. I'm using a simple 2N2222 transistor right here. Okay, and then here's my capacitors and the resistors and such. So I've got a ferrite bead just laying here. If I pick this transistor up, okay, and I'm going to slip that ferrite bead over the base and slide it back in. Okay, now with that on the base there, without doing anything else, that oscillation is now completely gone. Everything is nice and clean. Because essentially what's happened is, by putting that ferrite bead, right here in the base, I've introduced some loss at that very high frequency. This thing was oscillating at about 200 megahertz. So now at 200 megahertz, there's this lossy element in here, adding some delay and reducing that signal amplitude, that 200 megahertz signal amplitude, to the point where it doesn't induce an oscillation anymore in there. So sometimes you'll see circuits that have got ferrite beads, sitting on a lead, and that is most likely why, is just to suppress, some parasitic oscillation like that. So that's another kind of important application. Also, to reduce RF coupling, from circuits. I mean, if you're designing like an audio amplifier for a microphone that goes into an RF transmitter, you might use some ferrite beads on the power supplies and on the audio lines to keep the RF signal from coupling back into the amplifier itself. Now, there are different material types Sometimes they're called the mixes, and these different mixes are good for different frequency ranges. So you'll see mixes like 43, 31, 77. There's a whole series of numbers, and each of these mixes are good for particular frequency ranges. So what you probably want to do is kind of look at some of the more popular manufacturers, like Ferrite is one, Fair-Rite, Ferrite, Amidon, Murata. There's several other manufacturers, but they've got a lot of application information about, which mixes or which material mixes are suitable for various frequencies that you might be operating with. So you may want to consult some of their website material as well. So anyway, I hope this was a good introduction to what ferrites are and some of the applications of where they can be used for EMI suppression, like limiting the speed of some edges so they don't radiate a lot of energy, improve some power supply decoupling, control parasitic oscillation, etc. So, of course, any questions, let me know. But again, this is just intended to be just a little bit of an introduction to the topic. Thanks for watching.
That was good, wasn't it?
In today's video, we're going to talk.
Excuse me?
That was very good. I mean, as an electronic engineer myself, I don't think I've ever seen a better demonstration of the effect of one of those little beads when he just put that across those two things.
It brings it home, definitely.
Very, very simple, but very visual way of showing the effectiveness.
Yeah. Alrighty, so let's keep going here if I can get this back in sequence. So these are little clip-on things that you have. You see how they work. The more turns you can fit in here, the more impedance the little clip-on things will generate. The trick is don't put so many in that it doesn't make surface contact to surface contact. You got to have that. And if you run this through just a single time, like through here, they call that one turn. It comes through again and comes down. Now you've got two wires running through. That's 2 turns. So that's how you figure out how many turns of wire you got in there. One thing I will say, this will become important in a minute or two, they're coiled wires. Of course, that's what an inductor is, wires in a coil. So this thing will have a little bit of inductive reactance. Here are some different examples of how people use them in their shacks, different places. This company, Balun Designs, a lot of people are very pleased with the results of this particular company. So I thought I would mention them. And you can put these things like this shows here in series with each other and increase the effect of them. You don't not limited to just using one. And many of Balun Designs products have 2, one to kill the common mode current, a 1-to-1 Balun, and then they also have a 4-to-1 to match impedance later on. And having them in series like that improves the performance of the Balun. And here somebody just ran some coax through ferrite beads themselves and put some ends on the end of the coax. So you can roll your own. Here's another example of that. Some ferrite beads wrapped up with some heat shrink or electrical tape on the coax. You can buy these things here is a feed line choke. And one of them died on me, so I opened it up. And all it is just the beads slid around the outside of coax. And they've got some little resin and stuff to hold it in place a little bit. And that's really all that they are. Essentially the same thing as building your own. Very simple to do. One thing I'll point out is notice the physical size difference of ferrite beads. Tom Roush, W8JI, is going to make a comment about that in a few minutes down the road here. While we're here also, before we leave the coax construction, notice that there are a lot of parallel wires in the braid of coax, and that is essentially setting up a situation for capacitance too. So our common mode chokes and baluns can have both inductive and capacitive reactance as well as a resistance associated with it. Here's a company. I own this particular balun. I only run 100 watts, but they convinced me to get a 5 kilowatt balun. A lot of people thought I was out of my mind. But keep that thought in mind as we go through a little bit later on, and you'll begin to understand why a little bit. Note here that there's regular wire instead of coax on the inside of this. And part of the reason for that is if you coil up coax, and you have a mismatch in it, you're going to generate some heat inside of that coax if you have it run around in loops. And with the inside diameter of the coax, you actually can get migration of the center conductor because of the heat through, and there have been instances where you get a contact of a center conductor to the braid, and that's obviously not good for your radios. So they got regular wire instead of coax is recommended by many these days. And you've got both coiled and parallel wires, and implies kind of that this balun has a resonant frequency. And that happens whether you use regular wire or coax. So back to the where we want the balun is on the outside. We want a high impedance out there. Well, how much is high? Most people say that 1500 ohms is a good impedance to have, but 5,000 ohms is wanted by many, especially if you're using a high power, because the higher the power, the more common mode current you'll tend to have due to mismatches on the outside of the coax braid. The video talked a little bit about different mixes. I downloaded this from Palomar website, and I just chose these two because I have two turns in both cases at 10 megahertz. This is a 61 mix, this is a 43 mix, and you can see that with the same construction, I get a different impedance ratio out of it. And these peaks and changes occur at different frequencies. So you got to be careful what mix you choose, whether it'll solve your problem or not. And if you go to we call them Hamfest here, I don't know what they are in England over there, just a bunch of get-togethers and people selling things.
It's the same over here.
Okay. You don't know what you're getting sometimes. May or may not work for you, and that could be a reason why.
Actually,
Jim,
Kevin, sorry to interrupt, but a good friend of NARC's, or one of our members, Steve G0KY, strongly recommends when you buy any kind of ferrite or of any kind to label them when you get them, because there's no way of telling later on easily what they are. Sometimes they're painted a colour, but often they're just all look the same, don't they? So that's probably good advice, I guess.
Absolutely. I've got that problem here in my shack as well before I learned that. Jim thinks number 31 material is the magic mix to have. And he says that anywhere between 1.5 and 150 megahertz will work fairly well. He says you can get an 8-to-1 frequency span on this as compared to 4-to-1 for number 43. And it also has different characteristics at HF. We won't learn that here. I took this out of one of his things where he explains that later on, but we will talk about that concept. I wrote this top part, just like antennas, a choke will work best when it's used at or near the frequency it was designed. And a lot of my information came from one of the fellows over your way, a silent key now, Steve Hunt, G3TXQ. He says that you need to choose a choke which has a high impedance and is resistive over the frequency range of interest. I never heard that until I ran across his webpage and things he was talking about. And this is a graph showing for 73 and 43 material the impedance, to overall impedance, but it also shows the reactance and the resistance. And as you change frequency, you see that the curves change. And there's going to be a range where you mostly have resistance effect with impedance at 0. And that'll be the resonant frequency of where the balun design is, based upon all those little factors about the parallel and coiled up wires and etc. You want to try to operate a balun as close as you can as resonance. And that's not always known. G3TXQ had done a lot of study, and many of you may have seen this before. Put out a chart showing different turns with different cores and different material, different coax types. These are air cores, just coiled up coax. Well, let's zoom in on that a little bit more. And he's got these graphs up here. These black bars represent what he says is mainly resistive sections of the balun. So you would want to choose a balun that has mostly resistive across those ranges. And that's what the black bars symbolize. The green is good for the different ranges, and as you get outside of the ranges, it tends to get a little bit worse. The air-cooled air cord things where you just coil up coilless, they don't have a resistance value at all. So you ought to try to avoid them, although they do end up working. They're very reactive. If you look up here at this particular one, you can see you've got 12 turns of RG58 on a 31 mix versus 12 turns on a 43 mix, and you get different impedance values and different resistance ranges for those two. Now, an explanation, we said earlier, 1500 ohms is a lot of people want. Many people want more than 5. Here's a chart which explains what the impedance ratios are for those particular values. So if you're going out and you're choosing a choke, it's difficult to find a common mode choke that will cover the entire HF bandwidth, or if it covers HF, it's probably not going to cover VHF. And you can use this chart a little bit, like if you're doing something for 80 meters, right up here in these ranges are where you would want. There isn't really a case where the ones he looked at, where an air cord rapid coax will do much good on 80 meters. Now, one of the presentations I gave here, a man later asked, he says, you just said the air cord doesn't work at all, and I've used them and they help. They do give an impedance reduction, but again, it's reactive, not resistance. And you need 25 turns of RG58 and a 4.25 inch core to even get up around 1,000 ohms. 1,000 ohms may be enough to solve your particular problem. But again, many people think that you would want a little more than that. They do work. It's just they don't always work as well as some of the other options you have of putting some turns on a ferrite core. So that's why sometimes they tend to work and sometimes they don't. In general, the more turns there are on a given core, the higher the choke's impedance, but the narrower the bandwidth. And here we have 12 turns and 17 turns on the same core, and you can see the resistance portion goes down. You get a higher impedance on the more turns, but you get a less of a bandwidth on those turns as well. So that might be another reason why a balun in one particular situation isn't working for you that it might be in another. Another thing you're going to need to do is take a look at it. This was G3TXQ's testing of a RG58 on core 31 material. If you remember, K9YC said it was a magic material, but that graph didn't really all look that well. G3TXQ did that data in 2012. Well, he redid it in 2017 and came up with this, and I don't know what he did differently, but this is more in line with what K9YC was saying. It does cover a far greater range of the spectrum, so be aware that just because you may have learned something a long time ago and you think, well, that's how it is, there may be some updated information somewhere. Or if you're out searching on the web page, be sure to check more than one source because things do change from time to time. Now, the thing about reactive chokes is inductors and capacitors, they all affect each other in a circuit. And you may get a situation where the reactivity in your choke can resonate with the reactivity in your feed line, the common mode impedance path, and cancel each other out. And that can in fact cause more problems by inserting a balun because it cancels out the impedance path that you naturally have in your feed path. And that's what happened with that guy at the beginning, which says I put it in and I had worse problems. He probably had a situation like that. G3TXQ posed this scenario, essentially a dipole up in the air on 20 meters, and he said the feed line is coming vertically down. The picture kind of shows it going off the side, but and he said he's got a 20 ohm ground, and he analyzed it in his system. What he came up with was about 0.2 of an amp of total current going down his common mode braid, and that's not necessarily a good thing. He put a reactive choke in it in this design, and it just happened, this is the worst case scenario, to cancel out the natural impedance in the feed line. And instead of 0.2 of an amp, it went up to 0.64 amps. Well, naturally, putting that balun in that particular scenario makes it much more worse. But if you put in a balun which was a resistive, operated more at its resonant frequency, it dropped it way down and makes it even less of a problem. So that's why you want to get resistive chokes, so you don't have to worry so much about that particular problem. Now, resistive chokes do have an issue. Steve reached out to this gentleman and did a G8 JNJ, who was able to use an infrared device and look at the heating in a core. He ran 100 watts into it for 5 minutes. And the one on the left is a low permeability core. The material chosen doesn't pass magnetic flux all that well, as compared to the one on the right. And you can see that you end up with a situation, if you don't choose your material correctly or you exceed the power limit of the material, you can actually heat it up. And that happens on a regular basis. That was behind the comment of my balun burned up the other day. For high power applications, RG400 coax can be used. This is from Steve Hunt again, and he has that in his charts. I looked this up a little bit more, and some of the repeater builders here in the US recommend using that for VHF and UHF applications. It costs more, but it has better shielding than RG58 as well, so it's probably a better choice to use. K9YC has a lot of information about it. I pulled these off of his some of his things, some of his general rules. More impedance is better. All ferrite chokes should be designed to operate at the resistance is large and reactance is small. And these conditions are satisfied at or near the choke's resonant frequency. And you accomplish those things by selecting a suitable material, core size, and number of turns. This is from me. I strongly encourage everybody to read Jim K9YC's information about it. He put out a choke cookbook. He's actually got two, an old and a new. He doesn't recommend using the old one anymore. But just Google K9YC choke book, and I don't know, it's 40, 50, 60 pages long with all kinds of practical examples in it about how to roll your own. This is an old one. Again, he no longer recommends it because it's using RG8, RG6, RG11 coiled up, and that can cause the problems we mentioned earlier. Instead, he's gone to the wire thing similar to what I showed you with the DX Engineering balun and the Balun Designs baluns. And he actually lays out, if you want to get a choke for 160 to 80 meters, whether you've got RG400 Teflon wire or THHN wire, how much to use and what impedance you're going to get in those different ranges. And he's got table after table after table of those to use. So it's very useful information. Again, just Google K9YC cookbook and make sure you get the new one from him. A lot of people find that varying the length of coax affects how they get RF in their shack. And one thing that tends to happen that you see is if your antenna SWR is good at the antenna feed point, but not in the shack, old timers will often tell you, well, just change the length of your coax till you get a decent match. And that does tend to work, but it doesn't necessarily solve your common mode problem that's messing up some of the other issues that we saw in the earlier videos. I sometimes have seen that effect in my shack when I use an external SWR bridge at the end of the length of coax for my radio. The two will read different SWR readings, which tells me I've got some type of a problem on my feed line. So something to look at. NG3TXQ talked about it also. As we vary the length of the coax, the Braden path impedance changes, and that's likely to do with common mode current. When the coax is close to a quarter wavelength long, the common mode path is high impedance and relatively little current flows, whether we choose a choke or not. But there's no length of coax where an unlucky reactive impedance could not make things worse. Another reason to use the resistive chokes. This first part implies where you put a choke in the feed line can affect how well it works. Common mode chokes, current chokes do not necessarily work well when they don't have any common mode current flowing through them. So you may have a standing wave of common mode current on your feed line, and if you put the balun in the wrong spot, you won't see a difference. But if you put it somewhere different, you very well might. And this implies to avoid reactive chokes. So here's a graphical representation of it. If you put a choke there, or if you put your rig there, you wouldn't have any problem, even though you've got common mode choke. But if they were put in there, you have a potential problem. And if you have a multi-band antenna, like many of us do, these dips and nulls are going to occur at different places based on whatever frequency you're using. So another reason to not do it. And he says it gets more complex as you use multi-band antennas too. So Tom Roush, this is getting into a little bit more technical information. So we're familiar with this, may see one or two new things here, I don't know. But he likes to use mainly 73 material for receiving applications at low power. And that's between 0.1 and 30 megahertz. Tom runs a lot of beverages, and he's a 160 megahertz or 160 meter guru. And he says a downward slope in permeability with increasing frequency is useful for controlling impedance in broadband transformers. And this is a permeability graph of 73 material, and he likes to use it in those particular downward sloping regions that are there. And I include this stuff to let you know that there's a heck of a lot more to this. As I said, I'm not an expert, but if you're going to build your own and things aren't working right, you can do a lot of research and learn a lot of things from these people. He says for high power applications at HF, often necessary to use lower permeability cores though. Remember, that can generate more heat, but they have a lower loss tangent, which is the ability to generate heat, complicated way in proportion of the peak stored energy dissipated as heat during the charge and discharge cycle. Materials like 65, 61, or in extreme cases, 43 materials are what he likes to use for high power applications at HF. And he often says, we often assume heat means a core is very lossy or is saturating, but that often isn't true. You got to consider the power level, the duty cycle, and the ability of the core to dissipate heat, and look at the big picture. Remember the size of those different beads we talked about earlier. Very small cores, such as small, thin, half-inch diameter cores used on bead-type chokes, which is what we looked at earlier, can only dissipate a fraction of a watt in open air. And even a fraction of a dB loss produces significant heating in small cores when powers are in the kilowatt range. The loss difference in non-resonant applications between lower and high ferrite cores isn't much, but the ability of that balun to handle heat can be significantly different. So using those little tiny balun beads may not be the right choice for many of us. And on that about heating, SWR plays a big important fact of it as well. Rated power, this is from RadioWorks. They don't make baluns anymore, but they still have their website up. They were a respected balun maker. And in their literature, they say rated power assumes an SWR of less than 2 to 1, unless otherwise noted. Well, imagine putting your a balun, if it's only 2 to 1, in a doublet antenna that you're feeding with coax and trying to use an antenna tuner to match it. You're not going to have 2 to 1 at the other end. So because of that, the rated frequency of his baluns was also 3.5 meg, and the duty cycle is CW or SSB with normal processing. So what the mode you're using is important too. When a ferrite core balun saturates, and I have seen this in my equipment, you'll notice an upward drift in SWR long before the balun fails. Core saturation will be caused by too great a mismatch of the load or by running too much power combination. So you see your SWR start to drift up. Excuse me just a minute. If you see your SWR starting to drift up while operating, you probably got a balun or choke in your line. That could be what's happening to you. So reduce your power and continue or shut down if you can. Fix your problem. Let me get this back here again. This is from the Palomar system, and they have for sideband 50% on and off. Whatever their baluns were rated at, that's the 100% value. But if you start using heavy processing, they tell you to derate it by 75%. Same with CW. If you're doing continuous carrier work, it goes down to 43.75% of what their value are. And if your AM, FM are using some of the digital modes, it derates even further to just 31.25% of the rated power. So they're derating as these things go on. And if you look over here at the right, I said I had a 5,000 watt rated balun earlier, and people were snickering at me for 100 watts. Even though it's rated at 5,000, that derating alone brings it down to 1,563 watts. Well, that's still significantly above 100, but remember that's at a matched SWR of 2 to 1. I was using it to feed a 272 horizontal loop, 272 foot horizontal loop, which did not have a low SWR, so that would further cause derating of that value as well. So maybe it was overkill. A lot of you probably operate with much less, but I didn't want to have some problems occur, so I went overkill on that part of it. Here's another example. This is an inexpensive balun that's out there, and by the way, I'm not trashing this company, just pointing out a couple things to look at. Here's their description, and I brought it down and blew it up. Notice down here at the bottom, although this thing says its power rating is 1,500 watts, it's only 200 watts on CW. That's a reduction to 13% of the full rating for CW use. So you might think you're perfectly fine with 1,500 watts, and if you run a 400 watt amplifier, you know, I'm good to go. Not necessarily. That balun may not serve you well, so be sure you take a look at it. We're not going deeply into the difference between a current and voltage balun, but most people, unless you have a specific application that needs it, you should be getting a current balun, not a voltage balun, to reduce a lot of your problems. And this is a pictorial description of it. In a voltage balun, all the current through the shield and everything flows right through, kind of like an auto transformer, and goes out to the balanced load. Where in a current balun, it kind of uses current from both windings to set up magnetic fields and try to cancel out the current on the other side. So you don't get quite as much transfer of energy, this unwanted energy from the input to the output with a current balun as you do with a voltage balun. And in many cases, throwing a voltage balun in does absolutely nothing, which is another reason why people say that they don't seem to work for me. So I usually opt for a current balun whenever I can. In an unun, balun versus an unun, I'll just throw this in here for a quick thing. We're almost done here. This is how a 4-to-1 balun is wired. Notice from where it comes in, goes to here on the signer, and also this other one comes in here and goes to the side. This is on the balanced load. But if you've got a unbalanced to unbalanced feed line, in this case, point A is connected to ground and it's connected to the shield exactly opposite as it was there. So these will have different characteristics and have an effect on how well they work. An example of where you would want an unun is if you're using coax to feed a ground-mounted vertical antenna, which is an unbalanced antenna. You would want an unun instead of a balun. I have put baluns on it, and it does cut down on some common mode current. At least it did make a difference, but I really ought to be using ununs from that. But I figured I'd mention that. So we have several references. I'll put these up here so they're on the screen. You can check the video later and refer to them as needed. And here's a page 2. Spent a lot of time searching through this. And that's pretty much my presentation. Are there any questions?
Thank you very much, Kevin. So those references, obviously there's quite a lot there, but as always, we record this whole program, and although it's also available on Facebook, we record it here digitally and we upload that to YouTube in the next 24, 48 hours. So if you missed those references and you want to access them, and the same with the videos that you saw earlier where Kevin had put up the links, then all you need to do is look at the YouTube recording that we make, which is on the Norfolk Amateur Radio Club's YouTube channel. It'll be there in the next few days anyway. No questions so far, although we've only just asked for those, I think, Kevin. But one thing I'd like to read out, and I see that John has actually put something here. About 4 or 5 days ago, one of our members, John 2E0TWQ, wrote to me and said this, and I thought it was relevant to what you're probably going to be talking about. He said, on my Flex 3000 SDR, I'm at times suffering an echo on my speech when transmitting. This only happens on certain occasions on certain bands. I explained that I've tried different ways to eliminate it, but no effect. and I have high noise levels in the shack. I recently came across a YouTube video regarding line isolators done by Peter Waters G3JOV. In the video he explains the use of line isolators and what they can do in the shack to reduce RF and noise. He also said that it can prevent RF getting into your microphone circuit, which John assumes is what was causing the echo. Now that was something a few days ago, and he thought it might be relevant to tonight, or possibly the when we talk about the filters. But actually, and I know John said that he'd ordered some of these various toroids, and he's actually put something on our Facebook channel, Kevan, which if you don't mind, I'm going to read because I'm sure you've got a view on them. He said, just used an FT240-43 ferrite ring with 15 turns of RG58 on my antenna cable, which is going to a G5RV close to my Flex 3000 radio antenna input, and it has removed the RF echo on transmit on his microphone output successfully. So there's an example of how to use those ferrites in the right way to get rid of problems like that. Have you ever come across these line isolators?
I have line isolators in my own shack, as a matter of fact. And I apologize, I stopped sharing my screen on you. I hope you've got it back again.
That's okay.
But yes, that's exactly what we were talking about, basically, with putting the balun outside of the equipment with the larger voltage drop. The balun does not have to be right at the antenna to reduce common mode current, although that's where a lot of people put them. I gave a presentation, I think, on verticals last year. Mm-hmm. My vertical choices here, and I have an unknown out at the base of my inverted L, but then the coax runs to the house, even though it's underground, and comes into the house, and could have picked up energy on the outside of the coax in that run from the house. So I also have a line isolator right here at the back of the radios, where the feed line goes right to the radios to remove anything that might have been picked up. And that's the same situation he's talking about.
Yes, I'd never heard of the echo, I must admit, before. But
that's new to me too.
But it's good. It's solved the problem, and it just shows how wonderful these things are. As I said earlier, and by the way, I should just mention to everybody at home now, I'm sure they've been intent on watching this. We've got quite a lot of people watching this now, about 70 people or so. But if you want to ask questions or make comments or anything, or what your experiences is with ferrites or things like that, then please ask them right now. Because we're coming otherwise towards the end of our program. Yeah, I was mentioning earlier, that was a really good demonstration, wasn't it, on the effectiveness of some just tiny little cores. I've never seen anything quite as simple and effective as that.
It brings it all home. I couldn't resist presenting that to different people too. It was amazing.
Yeah, just using two sockets really, and then showing the output from a function generator and the input to a scope, and just showing the effectiveness of a parasitic bead. I've never seen that demonstrated before, I must admit. We've got a question, or a couple of things coming in now. Firstly from Ralph 2M0RHT, who, by the way, just earlier just commented on the fact that although the subtitles on Facebook may have been annoying to some, of course for some people with hard of hearing, including Ralph's wife, that can be a real lifeline for something like that. So I'm guessing this is a new feature on Facebook, and if you have difficulty in some of your hearing difficulties or anything like that, or you know someone who has and would like to watch something like NARC Live, it's a good feature to be able to switch on. But Ralph anyway comes back and says, how might one analyze a radio setup without all the extravagant equipment and things? Is there a way of doing it, do you know?
I assume this is in regards to having common mode current come in. And I hate to say this, but I'm not an expert at any of this by any means, but if I don't have any symptoms of common mode current, such as an echo and a flex, which was new to me, or RFI distortion in my microphone audio, or distortion reported on my signals, or as I mentioned about the SWR differences between an external meter and my rig, I've just naturally assumed I do not have some issues. But you can, I would think, take a coil of wire and coil it up and see if you have any difference, or there have to be devices which can measure the coax. So I regret to say I don't really know, but that would be what I would look for. If I have any symptoms that seem like it, then I would begin to do some more troubleshooting.
So I guess maybe having a small stock of some of these cores is pretty good if you can afford to spend. I mean, sometimes they're £5-10 or so in our money, and having something like this can be a useful thing if you do get symptoms. There's no real harm you can do by wrapping some wire, some of the RG58 or whatever you're using to connect up, to see if it's effective.
I will also add, as was mentioned in the picture, which showed the several different lines with ferrite beads wrapped on them, rather than, if you don't have any available, unplug unnecessary things one by one and see if your problem goes away.
Yeah, good. A process of elimination. Yeah, thank you. Mike G4DYC says, many thanks, Kevin. If a ferrite saturates or overheats, can their properties be permanently changed? Good question.
I'm going to pull out what little I know of physics and say the answer to that is yes. I would expect to have some perhaps micro deformities occur in the matrix of the ferrite bead material, and or small cracks develop inside, and that could in fact cause changes of it before it actually catastrophically failed. That's my supposition.
Yeah, that's okay. Kevin, I could just add another comment, if I may, or a question on that. I mentioned to you what Steve G0KY strongly recommends to anybody who buys ferrite, like one of these or one of these, when you get it, because they look so similar, it's a good idea to label them. But what happens if you go to a hamfest or a radio rally, as we sometimes call them over here, and you see some very cheaply in a box and you don't know what they are? Is there a way of telling what the characteristics are? Do you know of, without having some very expensive, elaborate equipment?
You can go online and Google the question itself. How do you verify the mix of a ferrite material? And there are several things out there that discuss how to do that. Essentially, it can be done with an antenna analyzer and your radio or a small RF generator or something along those lines. And you can come up with a good characterization of what the material is. The people tell me that it's fairly time consuming, which is why they're still sitting unmarked in my box. But
I bet we've all got that. But as I said, I did.
Yeah.
As you've heard, we've recently had a mains filter kit by GM3SEK. I don't know if you've come across Ian GM3SEK, but he gave us a really excellent talk on a mains filter, and lots of people bought one. And as it was a bit of advice that I gave everybody: when you get these things, please label them up, and don't do maybe what I originally thought. I've got one of these little thermal dymo label printers, and thinking about the heat now, I think that probably isn't the best thing to label them with, because if it gets hot, it's going to lose the markings. But anyway, Jim G3YLA says, great presentation, thank you. Is stacking FT240 cores effective for improving thermal capacity?
Not that I've heard for thermal capacity, other than the fact of the actual material itself. It's not going to affect the ability of the individual core to handle it. But by dissipating the energy drop across multiple cores, you are reducing the amount of heat being generated in each core, and that will affect the increase in capability of the balun.
Okay. Thanks. And the last question, unless you have another one at home now is the time to definitely ask it. Roger G3LDI asks, are there any definitions for ferrite rod? I used a piece with a trifilar winding on my 80-meter delta loop around 50 years ago. So I guess he's talking about, again, the mixes.
I'm not sure what we mean by definition. If you're talking about how to use them to make baluns, I'm pretty sure I remember seeing some things in K9YC's cookbook that discussed use of ferrite rods and some of the ranges that occurred with that. So I would take a look in there.
Okay, that sounds really good. Well, I think we've covered a lot there. It just so happens that in the last month, 6 weeks, we've done quite a lot on filtering and things like that. And as you heard, Kevin, next week we'll be returning to this the filter kit, the mains filter, to see how effective it's been, because so many people, we did a club purchase, basically a bulk purchase of things, of all the components that made them up, and it'll be interesting to see how they go. But the knowledge that you've imparted tonight and the experience helps us understand, I think, how much more we can get from a ferrite and a ballon, and how effective they can be and how useful they can be in the shack. And we're really grateful for you coming back. And I believe we've booked you again for a talk later in the year as well.
We have. I will mention, encourage people to go again, read K9YC's information on it. But I put in there Tom Roush, W8JI. He has a website filled extensively with information about this, and he was a design engineer, among other things, made the MFJ 259 analyzer and AL80B amplifiers, and he is a wealth of technical information that he can share. And I'll be looking forward to coming back next.
Yeah, we're looking forward to that as well. If you can actually, Kevin, and if you didn't mind, I know there was a lot of references, 2 pages of references at the end of your presentation. If you don't mind copying and pasting those and sending that on an email to me, then what I'll do is I'll put them on our newsletter. We have a little section with extra news and extra details about the club talks and things, and then people can probably more easily get them exactly right and click on the links and things like that. So if you don't mind doing that for me, that would be great.
No problem.
But once again, thank you very much indeed for coming on tonight, and we'll look forward to seeing you later in the year. Kevan N4XL, best wishes. Thank you.
Thank you.
Thanks very much to Kevin. And there we are. Now we know a lot more about ferrites and balluns. They really are useful things, but a bit of black magic, I must admit, probably until even 5 years ago, I think that most of these I thought were pretty much the same as each other, but they're definitely not, and they do lots of great jobs. And those videos that you linked us to again, I thought were really good tonight. So thank you very much to Kevin again, and thanks very much to everybody else as well for your stories and everything else that you've given us. Just a reminder again what's happening on the club this week. We've got the GB2RS news at 7 o'clock on Sunday on the repeater GB3MB. Also on GB3MB at 7:30 on Monday, we've got the Monday Night Net with Ken M0KJW, and at 8:30 the 80 meter CW net on 3.543 megahertz. And on Wednesday, the 2nd of February, remember this is an interactive, an informal interactive where we would love you to come on with Zoom, particularly if you made one of those mains filters, GM3SEK. Ian hopes to join us as well, and you'll be able to talk to him if you're on the Zoom call and live, and also ask questions, of course, on BATC and Facebook in the usual way. So it's really a follow-up to that project, and we'd love to hear how effective it's been for you for that filter. But that's it for this week for NARC Live. We'll look forward to seeing you next week. But until then, from Tammy M0TC.
Goodbye.
And from me, David G7ERP. Take care of yourselves. We'll see you next Wednesday for NARC Live. Bye-bye.